So in this lesson, we are going to look at the studio for custom vision, and we are going to look at object detection. Most of the AI services has a studio associated with it. Studio is nothing but just a UI interface to interact with it rather than the Python API. But behind the scenes, the studios call these REST APIs. Studio doesn't do any magic, just a UI for the REST API for interaction and making things easier for us. Almost all the services we have been seeing so far, as well as we will be seeing, has a studio with it. We'll see one by one. You can explore more on your own in the Azure AI portal. So this is the Custom Vision AI or the Custom Vision Studio. So you can go to it in many ways. One is directly go here to this particular URL, or from the Azure, you can go to that place as well. So for example, this is your model or the endpoint. And from here, you can click on this and it'll go to the Custom Vision AI. Sign in using your Azure credentials. So it is already signed in my case. Sometimes it asks for the username and password, and it automatically creates a different username and things like that. Doesn't matter to us much. So right now we can see our project here. So this is our project, the project which we have created in the previous lesson. So it gives us a visual representation of what we've been training the model. So these are the images the model is trained of. These are the images we have uploaded. So the reason why I put that deletion code in the beginning is because I wanted to show you this inside the Custom Vision Studio, the images of these training samples. So it is correctly saying that there is 10 hemlock and 10 Japanese cherry. All the images are tagged, as you can see here. And there is this thing called performance right here. So this is the precision, recall, and AP. So precision, this number will tell you if a tag is predicted by a model, how likely is that to be right. So basically, if it is saying hemlock, how accurate it is. How is the precision of the model to be saying that it is hemlock? That is this precision all about. So next is recall. This number will tell you out of the tags which should be predicted correctly. What percentage did your model correctly find? So this is about the correctness of the tags within different tags available to the model. That is recall. So AP is a measure of model performance, summarizes the precision and recall at different threshold. So all these values, higher the better. In our case, it is all 100%. So the model is quite sure about everything. So the tag it gave was correct, and the accuracy of that prediction was very accurate as well. 100% accuracy it has. You can give some other images and this number will change. If you do test with other images, these numbers varies accordingly. Here is the individual count of each items. Japanese cherry and hemlock, you can add more images and more tags so that you will see different numbers. This is looking very good so far. The model is quite comfortable with the images we are giving. That's what it means. It is able to correlate fully between those images. So higher these numbers, better it is. In my experience, they are kindly related. If one goes down, the other goes down. And obviously, this is a combination of these two, so this will go down as well. So that was the performance of the training, and this is the prediction. So we have predicted one image, that is this. Hemlock, it is 99.9 probability, it has said it is hemlock, and Japanese cherry, it was a very small number, so it is almost 0%. You can try more predictions, and depends on that, it varies. So the Custom Vision Studio is pretty useful that way to analyze the benchmark and things like that, and looking at our current status of the training and things like that. Now, one thing we can do here is add further images using the Custom Studio. We can add more images to the project and tag it and things like that. So basically what we have done using code, we can visually do it here. In fact, almost all the AI services from Microsoft is coming up with some kind of studio these days, but everything is accessible by APIs as well. Now, one of the things we can do here is delete this project. So we can delete the project from here so that we will clean up our endpoint or the model. We can delete the project, but I'll be deleting the project from the next sample we are going to look, which is the object detection in the custom vision. Very similar concept. It's just that it'll detect multiple objects within a particular image. Otherwise, it's pretty similar from our perspective. So let's have a look at that sample, the object detection in the custom vision. Again, the code looks pretty similar to endpoints, then the prediction endpoint and the training endpoint. All these things remains the same, just that I'm creating the prediction endpoint and trainer at the same place. In this case, you can do that as well in the previous one. I have given an iteration name, detect model. So line number 27 is a kind of a shortcut. To be honest, I'm not a fan of this kind of syntax, especially this kind of big lines. In my view, it is harder to read, although it is doing pretty trivial thing. At least here it is doing very trivial thing. But recently Python has, especially because of all the data science stuff, Python has a lot of syntax like this. So let me explain what it does. It is doing very simple thing. It is getting all the domains, something called the domains within the trainer.getDomains. And it is iterating through each domain and checking the domain type is matching these two conditions. The type is object detection and domain name is general. If that is case, it is returning that object here. That is what this whole line is doing. Yes, if you write the loop, there'll be a couple of lines, but does it worth? In my view, it worth, and it is more readable than doing something like this. A person who is coming from another programming language will be definitely confusing this kind of things. But unfortunately or fortunately, I'm isolated here, and this is how it is. So the idea here is getting the domain for object detection. So that is the idea of this particular line number 27. And where we are passing it when we create the project. So we need to create a project of type object detection. That's the idea here. Everything remains the same. So we got the object detection domain, and then we are deleting all the existing project, and then we are doing pretty similar things as before. So we are creating the project with UUID here, and we are passing the domain ID here, which we have got from that particular complicated line, which is this line number 27. And we are creating two tags like we did before. In this case, it is a fork and scissors tag we are creating. And here is something interesting. These are the regions of the images which we are going to look. For example, we have a fork image, and what matters is within this rectangle in this particular image. That's what this particular data structure is all about. So we have a data structure like that in each image. So to make things easy, let's have a look at the image. So these are the image. We have fork and scissors, and this is the test image, which is a fork. And these are the fork images we are having. So this is a fork image, this is another fork. All are different fork images we have here. Now that number is just a crop of the fork within this particular file or image. For example, in this image, there's a crop like this. The reason why the crop is done in this case is to make things clear to the model, because we are detecting an object. This image can have any number of objects within it. Although it just have one fork, it can have spoons, it can have plates, it can have a lot of other things. But we are saying we want to focus on the object which is within this particular rectangle right here. And that's exactly what we are trying to do here. We are defining a rectangle here within the image, and we are putting everything into a dictionary right here. We are doing same for scissors. Scissors also pretty much similar types of images, different types of scissors. Two different objects which we are trying to detect. And then pretty much the same thing we are doing. We did last time, adding the image with the tag. So in this case, when we append three things. One is a file, then the content, and then the regions. So this is something new we are adding to the tag image with regions. And then we are uploading, and then we are training just like we did before. And publishing, again, all same thing. And finally, we are predicting. Now let's have a look at the execution of the code. The breakpoint is going to be here so that we can see what this line is returning. So I'm going to start debugging. So like I mentioned, if you want to observe this particular line in detail, feel free, write every line of code which is there in this line number 27 to dissect it further if you want. for us, it has returned an object, and the object ID is this, and name is general, and type is object detection. That is exactly what we are filtering right here, like I mentioned before. Type equal to object detection, and domain name is general. Again, we are creating projects, getting projects, and trying to delete it. This is the same code from the previous thing. I have copy pasted here. Now, one of the things I would like to show you is we have this studio right here, the custom vision studio. So you see this is a project we are having. Now, what we can do is we'll come back to this and refresh this page after the execution of these lines. So what I'm going to do is I'm going to put a breakpoint in line number 42 and delete everything. So it has done. Now let's come back here and refresh the page. As you can see, this will be empty now. It has to be empty. Yeah, it is empty indeed. As you can see, it is saying create your first project, and that's what we are going to do. So we are going to execute creating a project and creating a tag and things. Now if we go back to the studio, let's see if something has come up. Yeah, the project has come up here, but it doesn't have any images. We'll be slowly adding. Now this is a region, so we'll have a look at this here after creating everything. Otherwise it doesn't worth spending our time. So this is just a dictionary with a couple of elements like this. This is the name of the file. If you look here, this is just the name of the file. It's the search _ 345. That's the name of the file. That is this key is all about. Now this is the base location and adding image. So we are taking the key from the previous array and we are going to iterate it through that files, getting the image data within that region. So I'm going to put a breakpoint here and execute it throughout. And let's look at this object right here. So we have fork _1 and then the regions right here. So the type of the object is a region within an image, and that's what we are giving to the model. So everything we are going to upload it here, and the input is tagged images with a region. Nothing complicated, just same as before. It's taking a little bit of time because it's an API call. Upload result is indeed successful. Let's refresh this to see if there is any changes. So the images has come up within the project. So the scissors, all the images are uploaded and the forks are all there. As you can see, there's a rectangle right here, which is that region we have given. So that's why it is focusing on that region, and the tag is fork. By the way, you can change things here if you want. That has that region correctly mentioned. So very clean training data. So there is no performance because we have not done any training. We are ready to train. We just uploaded the images, training images. There is no predictions as of now because we have not even trained the model. Just uploaded the object. Let's go back to the code, and our upload is successful. So we are now going to execute line number 119, 120, 121, and 122. We're going to skip that. And now the training going to happen. We'll have to wait for some time. I'm going to put a breakpoint here and wait. The training has started. Training is going on. So in the performance tab here in the Vision Studio, it is saying training. So the training is going on. So it was not training before. Right now it is in the training state. The state has changed in the performance. So the training has finished. Now next is publish iteration. So now let's have a look at the Vision Studio. So in this case, we have got our metrics. The precision is 100%. Recall is 87%. So it is not 100% sure about certain things. That's what this 87% is about. It is confused whether certain tags are certain images. This may point to the fact that you may need more images to get 100% accurate results. So the overall object detection looks good. The AP or the MAP and the precision looks good as well. Now let's publish it and test it. So publishing has done. Now the prediction should be 0. There won't be any predictions. If you want, you can get the endpoint from here. Now we are going to detect the image and we got the results. So let's watch the result. Add to watch. So these are the predictions. So in these predictions, there are quite a few entries out here. There are 17 entries, out of which with a probability of 81%, it's saying that there's a fork inside the image. So it is object detection with 81% of the probability. It is saying something is fork in the image. Let's see the other ones. So there is a fork with 0.83%. So that is very low probability. It is not sure that there is a fork. And there is something called bounding box. Bounding box is the bounding box within that image, just like we saw before, within that image where this object is present. So this is not good. So this probability or confidence level is very low. So this is unlikely to be a fork. In fact, this image we have given has only one fork inside it. So rest of the items are similar, very low probability. Probably there are some variations in the image we can't see, but the AI is finding out and it is trying to predict something out of it. But the probability is very low. As you can see, everywhere it is very low. Now let's refresh this prediction. So one prediction has been done. So that's what it is giving here. And threshold value is set. That's why this is showing like this, 15%. Only if it is above 15% we are showing. So 81.2%, there's a fork in this particular rectangle. That's what it is showing. So if we reduce the threshold value, we can see so many patches inside the image where it is showing very low probability for a fork. So that way it is pretty accurate. The training is giving accurate result. Feel free to test it with more images and samples. So we have seen the Vision Studio, the custom Vision Studio, and we have looked at object detection. So it is very similar to classification. It's just that it looks into the different parts of the image and find out different objects. So also we have seen the Vision Studio is very intuitive and easy to work with to understand things and try things out. But we will see the CI/CD process to automate this kind of things as well in one of the future presentations.